So today we're going to have a look at how the atmosphere of the Earth evolved from how it was about 4 billion years ago to how it got to today. So the problem we have when we're thinking about this is there isn't much evidence available. So scientists have come up with predictions and ideas to try and explain this, but there is so little evidence available, and the ideas change quite a lot all of the time. But the current idea is that the early Earth's atmosphere was probably quite similar to that of the way that Mars and Venus currently is. And that's because there was lots and lots of volcanic activity on the Earth's surface. So the Earth was very, very hot, and there's lots of volcanoes, and it's very, very different to how it was now. And there's volcanoes released two gases into the atmosphere. They released carbon dioxide gas, and they released water vapor, so water gas, into the atmosphere. Um, and then over time, as the Earth cooled down, the water vapor in the atmosphere started to condense. So I'm drawing a cloud here, and the water vapor started to condense. And we ended up with the formation of the Earth's oceans. So the Earth cools down, and the water vapor condenses. And starts to form the Earth's oceans. Don't forget that there's very little oxygen present. There's currently very little nitrogen present. Most of the atmosphere is still basically carbon dioxide. And then over the next 2 billion years, a process happens where this carbon dioxide gets removed from the atmosphere or locked up. The first way that it gets removed or locked up is to do with the oceans. So the carbon dioxide in the atmosphere starts to dissolve in the Earth's oceans, and that's actually something that still happens today. So small amounts of carbon dioxide does dissolve in the Earth's oceans, and it gets locked up as sedimentary rocks like limestone at the bottom of the Earth's oceans. So locked up as particularly carbonate rocks. So this word locked up means it's being taken out of the atmosphere and not released again. This will become important again later. So the carbon dioxide that was in the atmosphere starts to dissolve in the Earth's oceans, and then through a process of chemical reactions, it gets locked up at the bottom of the Earth, at the bottom of the oceans as carbonate rocks. So what happens next? Well, about 2 billion years ago, life starts to evolve. Now, early life is phytoplankton, or small organisms in the Earth's oceans that can carry out photosynthesis. But I'm going to think actually, just because it's easier for me to draw and easier for us to think about it as trees. Okay, so plant life is the first real life, or photosynthetic life is the first life that really evolves on the Earth's surface. And this again is a process that starts to remove carbon dioxide from the Earth's atmosphere and produces oxygen gas. So this is the first point at which we start to get oxygen produced in the atmosphere, and it's called the first great oxygenation event. So remember, this is the process called photosynthesis. Now, as this plant life grows, obviously over the course of about 500 million years, a lot of it's going to die. It's going to die with that carbon dioxide locked up in its structure, particularly as cellulose. So I'm trying to draw a dead tree here. So as our photosynthetic life dies, it gets locked up over the course of hundreds of millions of years as fossil fuels. So CO2 locked up as fossil fuels. If it's based on tree and plant life, then it's most likely to get locked up as coal. If it's aquatic organisms, it's more likely to get locked up as crude oil. So then this is another way that significant amounts of carbon dioxide end up getting locked up. Then we end up with, and obviously the process is more complicated but then fundamentally we end up with the atmosphere as we know it now, about 1/5 oxygen and then 4/5 nitrogen. And we haven't really spoken about where this nitrogen has come from. And it's believed that through various processes, nitrogen has just gradually increased in the Earth's atmosphere. Because it's very unreactive, it's not going to react, it doesn't get locked up in any way, it's just accumulated, probably through reactions involving methane and ammonia, particularly the reactions involving ammonia, and then obviously certain bacteria that produce nitrogen. So just as a summary, if we just think about what's happened here. So we're looking at how the Earth's atmosphere has evolved over time. Remember, it happened about 4 billion years ago. The evidence is very scarce. There's not much evidence available, and it's the ideas change quite a lot as new evidence comes to life. And because it happened such a long time ago, there isn't much evidence. So this is based on scientific models and scientific predictions. So we had volcanic activity that released lots of carbon dioxide and water vapor into the Earth's atmosphere. The atmosphere was probably, with that amount of carbon dioxide, very similar to how Mars and Venus is now. As the Earth cooled, the water vapor condensed to form the Earth's oceans. Some of the carbon dioxide in the atmosphere dissolved into the Earth's oceans and got locked up, so removed from the atmosphere as carbonate rocks. We then end up with life starting to evolve. Initially, life that carries out photosynthesis, so photosynthetic life, that takes in carbon dioxide and releases oxygen. So we start to increase the amount of oxygen in the Earth's atmosphere. Over time, a lot of this photosynthetic life dies and gets buried under layer and layer and layer of mud and starts to form fossil fuels, and therefore it gets locked up. And ultimately, we end up with the atmosphere as we understand it now, which is about 1/5 or 21% oxygen and about 4/5 or 78% nitrogen. The nitrogen is believed to have just built up over a period of time, over this whole process. Thank you very much.